Good afternoon, this is your captain speaking. My name is Play in a Crash. Please put on your seatbelts and get ready for takeoff. Oh no, what was that?
The chaos and panic as passengers scramble to escape the blaze.
No need to worry, folks. The engine seems to be malfunctioning a bit, but we have it all under control. We have our esteemed plane mechanic, just in time, working on the problem over the phone right now. Hello, this is just in time. What seems to be the problem here? The engine's broken! Oh, this seems like a simple matrix problem. I'm on it. Alright, so the first problem asks us to let A equal the matrix 1, 1/2, 0, 0, and to compute this sum. So this is equal to A. So this sum basically just means that the first term in our series is going to be this matrix raised to the first power, then it's going to be this matrix raised to the second power, and we're going to keep adding those together to get the second term. So the second term is going to actually just be the same matrix as the previous matrix. So we're just summing the same thing over and over and over again, because no matter what power you raise this matrix to, it's always going to be the same matrix. And so now we just want to find this sum, which is just going to be this, add it to itself 100 times. An easy way to do this is 100 times this matrix, and you see this equals the same thing. So therefore the answer is 150, 0, 0. So for part B, we want to find the sum of 1, 1, 0, 1 raised to even powers, and the sum of these parts of the matrix equals 1258. And we want to determine the number of terms in this sequence if all of this is true. And if we square this, we find that the first term in our sequence is going to be 1, 2, 0, 1. And you can see through this pattern that the rightmost term is increasing every time you raise it to a new power by 1. But the other terms in the matrix are constant. So this leftmost term is always going to be 1, this term is always going to be 0, and this term is always going to be 1. And the reason why this all works is because when you multiply the matrix by itself, only the rightmost term is not multiplied by 0, so it's the only one increasing. We want to find A plus B plus C plus D. So we get, for A is going to equal 1 plus 1 plus 1 dot dot dot. So this is just equal to n. And so is D. C equals 0. And then we have our rightmost term, which increases by 1 every time you raise it to a new power. And we're only looking at even powers, so our sequence is going to look like 2, 4, 6, 8. And so this is an arithmetic sequence where each term is increased by 2 each time. So we have a formula for arithmetic sequences. So then this plus A plus another n, and that equals 1258. And we want to solve this for n. And we find that n equals negative 37, which just can't happen. So 34 is n. We have 34, 1190, and 34. And when we add these to each other, it equals 1258. And now for our final problem, we want to find a closed form expression for Cn. Here we can see that the first term is 1101. For this one, it's the sum of b plus b squared plus b cubed, and then that plus the previous two terms. Notice that these numbers, they're all triangular numbers. And then you can notice that on the rightmost term, those are all tetrahedral numbers. So for triangular numbers, 1 is a triangular number, but so is 3, because you can make a triangle, and so is 6, and so forth. And then we have a way to find a formula for the triangular numbers. And the way we do this is we just add the same number in a different pattern, so it interlocks as a rectangle. And now that we have this rectangle, we can calculate exactly its area. And now we just want this. We just want a formula for the triangular number. So we just want the black dots. So we just divide this by 2 because the red dots, we can get rid of them. So this is basically our formula. N times n plus 1 over 2. And for a tetrahedral number, we have a similar thing, but it's kind of probably beyond the scope of this video. The proof is right here. Basically, the formula for a tetrahedral number is n times n plus 1 times n plus 2 over 6. And then remember for a tetrahedral number, and then remember that this is just going to be 0. So this is the closed format for c to the n. Wait, that didn't help at all. I mean, it was just theoretical. Oh no, we're going to hit Jack!